Okay, so we've got 5 plus 54x minus 2x cubed, and then we are looking for the absolute max and min. These are our guided practice 20 from section 4.1. So let's see, we're going to jump in and find our critical points first. So f prime of x equals 54 minus 6x, set that equal to 0. Oh, x squared. Let's see, that's 6x squared is equal to 54. Divide by 6 is going to give you x squared equals 9. Take the square root, that gives us x equals, oh, wait a second, hold on. One thing that we had to check up here. The reason why we went with pi over 3 and 5 pi over 3 and not any coterminal angles is because whatever your critical points are have to fit within the specified interval. So they have to be between 0 and 2 pi. That's also something we should check up here, which 0 and 2 were within our closed interval for the lecture, just to let you know. Something we should always be checking. This gives us plus and minus 3. And the reason I say this is because when we look at these two critical points and we look at this interval over here, negative 3 is not between 0 and 4. So I'm going to throw that one away. Okay, so I'm only going to use x equals 3 as the critical point within that window. So I'm going to check f of 0, f of 3, and f of 4. I'm not going to check f of negative 3. When you plug in 0 here, you get 5, which is nice. When you plug in 3, we get 5 plus 54 times 3, which is 162. And 3 squared is 9 times 2 is 18, so minus 18. So we're going to add 5 and subtract 18 from 162 to get 149. And I'm putting this in the wrong place. It goes down here. There we go. All right, and then for 4, we've got 5 plus 54 times 4, which is 216. And I did this wrong again. Back the train up. All right, so when we plugged in 3, we got 5. 54 times 3 was 162. 3 cubed is 27. 27, times 2 would be 54. So we're subtracting 54. So let's try that. 162 minus 54 minus 5 gives me 103. Okay, there we go. Now back to 4. We plugged in 4. The 5 stays. 5 times 4 was 216. 4 cubed is 64 times 2 gives us 128. So we're subtracting 128. So 216 minus 128 plus 5 is 93. And so I'm looking for the smallest and the largest. So my smallest is this one. So we have an absolute min at x equals 0. And my largest is the 103. So we have an absolute max at x equals 3. Okay. Next, we've got x plus 1 over x. All right, let's jump in here and see if we can find our critical points. So this is going to be 1 minus 1 over x squared, right? Because this is x to the negative 1. So its derivative is negative x to the negative 2, or negative 1 over x squared. We're setting this equal to 0. So you've got 1 over x squared. Move to the other side, so it's got to be equal to 1. Multiply both sides by x squared tells you x squared equals 1. And again, if you would take the square root here, you get plus or minus 1. But we want to check that interval, and that interval is from 0.2 up to 4. So that means we're going to throw out the negative and just keep the x equals 1. Okay, and that means I'm going to check f of 1, f of 0.2, and f of 4. I want that critical point plus my 2 endpoints. And I'm going to check to see what happens. So when we plug in 1, we get 1 plus 1 over 1, and that's 2. We get 0.2 plus 1 over 0.2. 1 over 0.2 is going to be 5, plus 0.2 is going to be 5.2. And then for 4, you're taking 4 plus 1 over 4, and that's going to give you 4.25. And so based on this information, our smallest is the 2. So we have an absolute min at x equals 1, and our largest is the 5.2. So we have an absolute max at x equals 0.2.